Why do newborns seek the breast, or ducklings follow their mother? From the very first moments of life, animals and humans show behaviors they were never taught. These actions aren't learned, they are wired into the brain as instincts. Like blueprints that serve as layouts for cities, instincts provide the master plan for life's essentials: food, safety, social bonds. Experience and learning build on this plan, adding depth and nuance that allow each individual to navigate and adapt to its surroundings. In this episode, we'll show the interplay between instincts and emotions. How emotions trigger instincts and how instincts evoke emotions. Do animals have emotions, and if so, how do we know? Could emotions be more than just human, something deeper, something instinctive? To find out, we must examine the patterns of behavior and the neural systems behind them. We cannot truly know what a sea turtle hatchling feels as it rushes to the waves, what a mother cow experiences as she nuzzles her calf, or why prairie voles bond for life while meadow voles remain promiscuous. But these behaviors stem from innate neural networks, deeply embedded circuits that regulate actions much like our own. While we can't access their inner worlds, we can observe behaviors that mirror human emotions. The hatchling's urgency suggests a drive for safety, an instinctive pull toward the ocean. The mother cow's gentle care reflects maternal attachment, while the calf's clinging evokes feelings of trust and security, much like a human infant's bond with a parent. Prairie voles exhibit affection and loyalty, contrasting with the meadow vole's impulsivity and promiscuity. These behaviors are not random but encoded in neural networks shaped by evolution. Similarly, human emotions like love, fear, and desire are expressed through activated neural circuits. Both humans and animals are born with innate instincts embedded in their neural networks. These networks, activated by innate cues, regulate physical and emotional responses, which in turn trigger other instincts, expanding into new behavior patterns. Let's now explore key instincts that shape emotional development and influence behavior. Caregiving and care receiving are two interrelated umbrella instincts that give rise to a wide range of sub-instincts and behaviors. Many of these sub-instincts are triggered by compound cues, signals made up of two components: one that activates a type of behavior, such as feeding, reproduction, or exploration, and another that evokes the emotional tone of that behavior, such as desire, comfort, or vulnerability. Emotions are not just byproducts of instinct, they're an integral part of how instincts work. They influence the likelihood that a behavior will actually be carried out. Take, for example, a mouse hiding in its hole. Its feeding instinct makes it desire the piece of cheese outside. But its safety instinct makes it aware of the nearby cat. The decision it makes depends on the relative strength of these competing emotions, desire versus fear. Humans and animals enter the world with built-in compound cues that spark their instincts into action. Over time, experience teaches them new compound cues, expanding those original instinctive patterns. Most of these new cues are learned through associative mechanisms, the most famous example being Pavlov's classical conditioning. Let's take a quick look. Before conditioning, as the dog hears the sound of a bell, it does not react by salivation, just by a neutral response to a neutral sound. The bell has no special meaning to the dog. It's not connected to any instinct. Also, before conditioning, as the dog is shown a piece of meat, it salivates. The smell of the meat is an innate cue hardwired into the brain to activate the feeding instinct. The dog salivates automatically. This is a built-in behavior, triggered by a natural stimulus. Then comes the pairing. The bell rings as the meat is presented. This happens again and again. Gradually, the dog's brain connects the ring of the bell with the meat. After that, when the bell rings, even if the meat doesn't appear, the dog salivates. The bell has become a learned cue. One that now triggers the feeding instinct on its own. The instinct has expanded, and so has the behavior. This process, called associative conditioning, was discovered by Pavlov and became central to behaviorism. The general principle behind Pavlov's conditioning is this: initially, there are neutral stimuli that do not trigger a certain innate instinct. There are stimuli that trigger that instinct. These are called innate cues. When a neutral stimulus is repeatedly paired with an innate cue, it becomes a learned cue that can also activate the instinct. However, the exact response triggered by a learned cue can vary across species and individuals. An instinct orchestrates the activities of multiple brain functions, and any given cue may be directly connected to only some of them. Which functions are affected by an expanded cue depends on the connections among sensory centers, motor control centers, executive regions, and memory systems. These neural architectures vary across species and individuals, contributing to the wide variation in how learned cues influence behavior. Different behaviors can evoke similar emotions, such as comfort, which may arise from eating, a hug, or intimate touch. Though the behaviors vary, the underlying emotional experience involves overlapping brain systems like the hypothalamus, amygdala, and insula, mediated by neurotransmitters like oxytocin and dopamine. Yet, the physical sources differ. Comfort from eating engages the digestive system, a hug involves touch, and intimacy involves the sexual system. Despite these differences, shared neural mechanisms create continuity in emotional experiences across different contexts and throughout life. A big part of who we become comes from how we interact with others, and those interactions are inseparable from our instincts. In Part 3 of Instincts Explained, we'll explore how instincts shape our connections with people and guide social learning. You definitely won't want to miss this one. Tap to keep watching.